I'd like you to imagine that you're an astronomer and you're searching for signs of extraterrestrial life on exoplanets. What would you look for? What environments could alien life exist in? And what would the fundamental chemical building blocks even be? But before we can answer these questions, we first have to understand how life on Earth first arose from non-living, abiotic molecules. This theory is known as abiogenesis. So, proteins, DNA and RNA are three of the most fundamental chemical building blocks of all life on Earth. But coming up with theories for how they first originated is very difficult, as they're all very interdependent, meaning that they rely on each other to be synthesized and formed. DNA relies on proteins like DNA polymerase to be replicated. RNA relies on proteins and DNA to be synthesized. And proteins rely on DNA and RNA in the processes of transcription and translation to also be produced. So how could these molecules have first formed without each other if they're so reliant on each other to exist in the first place? The water paradox makes this problem even more challenging, as it's generally accepted that life first began in the oceans, as early fossil evidence of the simplest, earliest life is aquatic. But how could molecules like DNA, RNA, and proteins begin in the water if they all have the potential to spontaneously hydrolyze or break down in aqueous conditions? Finally, there is the chirality problem. So in organic chemistry, many molecules exist as chiral molecules, which are two non-superimposable mirror images of each other, like your hands. And these different chiral molecules are called enantiomers, and you have right-handed and left-handed enantiomers, which have different chemical properties. And so in many biological reactions, you use only one type of enantiomer, which is called homochirality, as you're using only one type of chiral molecule. However, natural, non-biological reactions typically produce a 50-50 split of enantiomers, which raises the question of how homochirality could have arisen in a world where there was an equal concentration of both right-handed and left-handed enantiomers. So there are a few current theories which aim to explain abiogenesis, but they do have some limitations. The first one is the hydrothermal vent hypothesis, which states that hydrothermal vents, which are hot geysers in the ocean floor formed by tectonic activity, could have had the correct elements and chemicals to provide the basic building blocks for monomers of the polymers that make up life. And the hot temperatures could have catalyzed the formation of these molecules, of these monomers, into polymers. Furthermore, the porous metal surfaces of hydrothermal vents could have acted as a catalyst to further increase the rate of this polymerization. However, they can reach extreme temperatures of up to 400 degrees Celsius, which could have caused these molecules to break down as these conditions were too extreme for them to form larger complex forms, because it was just simply too hot. Secondly, we have the primordial soup hypothesis, which states that the early Earth's atmosphere was very reducing, and this, combined with lightning strikes and chemicals and elements in the oceans, could have provided the perfect environment for organic molecules and monomers to form. And in 1953, two scientists known as Miller and Urey performed an experiment to test this hypothesis. They recreated the conditions of the primordial soup and used electric shocks to simulate lightning. And what they found was really interesting. They actually managed to produce a range of amino acids, which are the monomers of proteins. However, they failed to explain the step from simple monomers to active metabolism, as they couldn't explain how these molecules could have formed proteins without enzymes, non-enzymatically. So, what is the solution to abiogenesis? I believe it is something called RNA world hypothesis, which states that the first metabolic reactions and the earliest life were based off of self-synthesizing RNA molecules. And in February of this year, a molecule known as QT45, quite tiny, which is what QT stands for, and it only has 45 nucleotides. And this RNA molecule is actually able to replicate itself, acting as both an enzyme and a storage genetic material. And experiments with this molecule in something called eutectic ice, which would mimic the environment of the early ocean, showed that over a period of 72 days, it was able to produce a 0.2% yield of complementary strands. And while this is an extremely slow process, it does show that given enough time, as there would have been in the early Earth, molecules like QT45 could have provided they could have acted as the first enzymes for metabolic reactions. And one explanation for how they could have formed is something that Darwin came up with in 1871, which is the warm little ponds hypothesis, which states that warm bodies of water produced by tectonic activity could have, and with wet and extreme defined wet and dry cycles, could have promoted polymerization of self-replicating RNA molecules. And they may have combined with something called protocells, which are simple spheres of a phospholipid bilayer, which is what all membranes are made out of. And by carrying out these reactions inside protocells, they would have been protected by external changes to their environment. So what does this mean for the search for extraterrestrial life? So we can narrow down what environments we look for when we search for alien life. So we can look for planets like TRAPPIST-1e, which is 40 light years away, and we believe that it has liquid water on the surface, as well as tectonic activity. So volcanic island arcs may exist, which could house these warm little ponds for RNA-based life to form. And it can also help us look for fossil and geological evidence of life that may exist in the past. So on Mars, rovers like Perseverance can search for phosphates and borates in dried up lakes and oceans, which could potentially suggest that these warm little ponds may have existed on Mars about 4 billion years ago. So early Mars may have been very similar to early Earth, and life, very similar life, may have existed on both. So hopefully, RNA world hypothesis can, at some point in the future, aim to answer the question of whether or not we truly are alone in the universe.